everyone. My name is Patrick Trail. I am the Research and Extension Coordinator here at Eco Asia. I'm coming to you from the Eco Asia Small Farm Resource Center based in Chiang Mai, Thailand. And we wish you could be here with us on the farm. We understand that's not possible. So today, we're going to do things a little differently. We're going to talk about this topic of biochar, and we're going to do it virtually. We're going to talk about biochar. What is it? How do we use it? Why do we use it? What are some of the benefits? And so today I'll be your teacher, and I'm going to be walking through this topic online in the classroom, and hopefully we can show you some of the hands-on practical ways that we use this material. So join me in the classroom, and see you later. Okay, let's jump right in here with this topic of biochar, and we're going to do a quick overview of a very big topic, and we're going to talk about what is biochar, how do we make it, and how do we use it. And so there's a lot to cover, so here we go. Okay, so to cover this topic of biochar, we need to cover a few key terms first. And so first I want to talk about carbon. What is carbon? Because carbon is what makes up this material that we call biochar, and which I will explain further later. But carbon is essentially the building block of life. It's in all organic material. It's in leaves, sticks, plants, manure, and carbon is what forms this black material that we call charcoal, or what we will later call biochar. Also, we're going to be talking a lot about biomass. And biomass is just any carbon-based material. And so that could be leaves, sticks, manure, compost. There are a lot of different carbon-based materials. But for the purposes of this training, we'll be talking about waste material that we find on the farm. And that's what we want to use to make our biochar. Okay, so when we talk about making biochar, what we're really talking about is essentially making charcoal. And I think most people in most places are familiar with how to make charcoal. And basically, that process just differs a little bit from a typical fire, which would be the combustion process. So combustion is happening in the presence of oxygen or air with heat. Pyrolysis is a process of thermal decomposition in the absence of oxygen. So it's a process of burning material with high heat and low oxygen. And that pyrolysis process is how we make charcoal, which we will talk about is what is later turned into biochar. So as we do this process, as we make charcoal using pyrolysis, it's a way to take on-farm waste. It's a way to take old bamboo trellises, sticks, leaves, different biomass that we've already talked about. Instead of burning it in a typical setting where we lose all of the carbon through smoke to the atmosphere, we can do a process of pyrolysis where we will keep the carbon intact and we will produce this material we call charcoal, and later turn that into what we call biochar. So doing this process of pyrolysis, it's a way to keep that carbon and keep it stable, and that way we can use it for different things instead of losing it. Instead of losing our carbon and nutrients to the atmosphere, we can keep it on our farm and use it for soil amendment, water filtration, potting mixes, different things that we'll talk about. So the process of pyrolysis is essentially what we call charcoal, making charcoal. And so charcoal on its own does not have much value. It does not have a great use on our farm. But when we mix that charcoal, that carbonized material that's been undergoing the process of pyrolysis We mix it with compost or other nutrient-rich materials, fertilizer, compost, manure, and together those two things are what become biochar. So when we talk about biochar, it is the combination of charcoal plus a nutrient source, and often that includes biological life, microorganisms, things that are beneficial to the soil. And so that is what we will refer to now as biochar. So how does biochar work? So like I said, we will take materials from the farm, waste products. We are not advocating for anyone to cut down trees or lead to further deforestation in order to make biochar. What we're saying is this is a way to take a waste product on the farm and turn it into something useful. So that can be bamboo, manure, corn cobs, rice hulls, coffee parchment, wood chips. There are any number of things found on the farm that can be used to turn into charcoal or biochar. So when we do this, when we go through this process of pyrolysis, when we burn these materials in a high heat, low oxygen environment, what we end up with is this material that looks like charcoal, and it's very black, very solid. But if you looked at it under a microscope, it's highly porous. It's filled with billions and billions of holes, just like you can see in the photo here. And this material, these pores act like a sponge. And this material that we call biochar has the ability to hold nutrients, hold water, house microorganisms, and it acts like a sponge. And when we mix that with soil, it becomes a very beneficial soil amendment or soil conditioner that we can use in our garden spaces, on our farms, in our potting mixes, around our fruit trees. And it's because it has this high surface area and porosity capable of holding on to many things, such as nutrients, microbes, and even water. So if we look at the chemical structure of this material, of charcoal or carbonized material, it also has an electrical charge, which means it is able to absorb chemical and nutrient components. It can latch on something like a magnet, and it can hold on to many things, such as nutrients that are needed for plant uptake. So we've talked a little bit about it already, but why biochar? Why go through the trouble of making this material? Well, there's a lot of reasons for it, and if we zoom out and look on the kind of the global scale, it is one way to address some of the climate change issues that we see happening in our world. So as fossil fuels are burnt, as fires are burning, we are losing carbon that is in our forests and in our trees and in our soil. We're losing it to the atmosphere through burning, through smoke, through combustion of fossil fuels and cars and industry. And we're losing a lot of that carbon from the soil where it belongs to the atmosphere where it is being detrimental and leading to further climate change. So here in Southeast Asia, here in Thailand, we have a huge issue with burning every smoke season in April, May, and the dry season. A lot of the forest and crop residues surrounding areas are burned, and that's done for a variety of reasons to clear farmland and forests. But when we burn all that carbon that's locked up in leaves and trees and stakes, it's going up in smoke, literally going up in smoke, and we are losing it to the atmosphere. So biochar is one potential solution for this. So instead of losing that carbon like we do in a typical fire, we can go through this process of pyrolysis, and we can actually keep it, and we can keep the carbon on our farms and in our soil, and where we can actually take advantage of it and use it to help the production and productivity of our crops. So what are some of the benefits of biochar? I've already mentioned this, but one of the key reasons that we make and use biochar is for amending soil. It is a highly beneficial material when mixed with compost, manure, And biochar we can use it in our soil. It increases the texture of our soil. So if we have high clays and we're mixing in biochar, it can help the tilth or the workability of the soil. Like I said, it has a high chemical absorption capacity, or what we call cation exchange capacity, and can hold on to nutrients and different cations and ions that the plants are needing for uptake. This material also has a high pH. So in many parts of the world, there are acidic soils, so it's low pH. So when we mix biochar in with our soils, we can actually improve the acidity of the soil and neutralize the soil pH to some degree, which is beneficial for many plants and nutrient uptake in the acidic soils of the world. And then lastly, we can improve microbial diversity. So biochar has been referred to as the house for microbes, and it's a place where microbes in those tiny porous holes can live and hide, and we get an increase in microbial activity in our soil, which is a good thing for soil nutrient cycling, and that's a good thing. So here is just a quick little example of how we how biochar can benefit your soil. So if you look on the right, these are rice seedlings grown in a mixture with biochar, and on the left without. So you can see a clear difference here, not only in the height and size of the seedlings, but the color too, which infers better nutrient component. Another advantage of making biochar is making what we call activated charcoal. And this is done in the same way, using this process of pyrolysis. And high quality activated charcoal can be used in water filtration. So just like I said, the highly porous material and electrical charge that the biochar has is good for absorbing and adsorbing metals, chemicals, and pathogens. And so we can use activated charcoal as one component in a biosand water filtration system. And so we have other materials on how to do that, and you can learn how to make those. But one of the key components for that is a high quality activated charcoal. And it acts in a powerful way to absorb pathogens and materials we don't want in our water. And then the last thing we're going to talk about is using charcoal or carbonized material as a way to run a combustion engine. So this is pretty exciting. This is a really amazing way to use a waste material on our farm. You can actually take waste biomass, carbon-based material that's on every farm and would usually be burned and thrown away. We can actually use it to run as a biofuel of sorts, and can be used to run a small combustion engine. And that can be used for multiple different uses. So you can just see here the components, but we've attached on to the combustion engine. We have the column here. Inside the vertical column, we have a small amount of carbonized material, charcoal being burned, and that's being pulled through the combustion engine. So an engine can be used off-grid. And to get it going, we do need a small fan to circulate through the combustion engine, but that can actually be a small battery-powered fan can be used to do that, to get it going. But once it's running, we can do this entirely off-grid with no electricity, and can be used for different things like pumping water and running different things on the farm that we might need a small engine for, such as irrigation pumps and other things. So here you can see our farm manager. He has just started up the engine, the combustion engine, using carbonized material, using charcoal. And you can see him here using the engine to pump water, and that's done entirely off of pyrolyzed material. So that's pretty amazing. Okay, now we're going to move into some different ways of making pyrolyzed material or carbon-based material, carbonized material that we've talked about. And so there's some different ways to do that. We have some different technologies and techniques for doing that and making it at different levels. So we'll start here with the simple gasifier cook stove. This is something that can be used in the household level, using small amounts of fuel at a time. But we can use rice hulls or corn cobs or any number of small biomass materials to run a cook stove. So this one actually is hooked up to a fan. We do use a fan to run some airflow through this one so that it works properly, and we can adjust the power and the heat of the stove. But at the end of the day, we are cooking our food. It's a clean burn, and it's smokeless. So if you're cooking over an open fire every day, this is an alternative way of cooking over an open fire and breathing in all of that smoke every day. It's a clean burn. And at the end of the day, when you're done burning and done cooking, you have left over this carbonized material that can be, again, mixed with compost and fertilizer and turned into biochar. And it could be put back on to the kitchen garden or the farm, or however you choose to use it. This is a way to do it a little bit larger scale. It's a 200-liter barrel. This is a common way of making charcoal. We call this the top lit updraft system, or TLUD, and it's a very simple way of making pyrolyzed material using our on-farm waste. So what we do is we light the fire at the top, and it pulls air through holes in the bottom of the barrel. It's high heat and low oxygen. The barrel keeps most of the oxygen out, and the flame itself stays on top of the material and is not actually contacting most of the material, but it is pushing down what we call a pyrolytic front here. And so as we burn, as the flame on top burns, it will draw and push down a pyrolytic front, or an oxygen-free zone, and that material will be carbonized and turned black, and the carbon will stay in place while the fire burns on top. So when we're done with that, we'll quench it with water, and we'll stop the process, and we will prevent the remaining material in the barrel from turning to ash. We don't want it to turn to ash. We want to pyrolyze the material so it all turns black, and then put it out so that we can kind of keep all of that carbon-based material. All right, so here's what we call a retort biochar kiln. This is getting a little more sophisticated, but basically we have the drum filled with our biomass, and it is completely removed and out of contact with the flame. So if you look here, you can see how the biomass is surrounding the barrel, inside of the barrel. And so the biomass inside of this barrel is not contacting flame at all, and it is being heated up in a completely oxygen free environment. And again, we use the TLUD method, top lit updraft, and then the chimney helps create a draft and get a really, really high heat. So taking it one step further, we can also use a retort biochar system that also simultaneously will produce wood vinegar. And wood vinegar is basically just another word for liquid smoke. And if we can collect that smoke, that liquid smoke, it can actually be used as a material for on-farm pesticides, kind of natural, organically made pesticide that can be sprayed on crops to kill soft-bodied insects. So in this system here, you can see here inside the main compartment, we have all of our biomass. It could be corn cobs, it could be small chunks of wood, it could be pieces of bamboo, whatever it is that we have on the farm. That's inside of the barrel. And then below that, we have the flame. And in this case, the flame does not come in direct contact with the biomass at all. And then on this system, we have this extra component here, and it basically funnels the smoke, and we have a condenser with cool water running through it, and out comes what we call liquid smoke or wood vinegar. So in this case, we are getting both biochar or carbonized material and wood vinegar, and this is the system we really prefer to use on our farm, and we can make a higher quality charcoal that doesn't break down into ash at all. It's just solid carbon. All right, so it's hard to probably figure out how to do this over a virtual slideshow, so we're going to just kind of try to give you a few more tips and clips on how to do this, how to set these up to make this training a little bit more practical. We'd prefer that you could come see us in person or that we could be there with you, but we're going to try to do our best to explain this over the internet. All right, so here we are on the farm making biochar using the system, the top-lit updraft system. So you saw the holes in the bottom of the barrel, and that's used for airflow. We don't want much airflow, so that's why we just have a few small holes in the bottom. Here you can see we're loading the biochar barrel with eucalyptus. In this case, we're using small chunks. We like to cut them down to the same size. It helps for a better and more uniform burn. And then we're doing the top lit updraft. So you can see that we get the fire going on the top here, and that flame, that open orange flame, pretty much stays on top of the material and does not contact the bulk of the material throughout the process. So it takes a little while to get going, but not too difficult to get that going. Obviously, the drier your material, the easier it will be to burn. All right, so now we've put on the top, and here goes the chimney. And when we put the chimney on, this helps create a draft. And it's amazing how this simple addition of a chimney will really start to draw air through the bottom holes, and it will really pull air up quickly. And that helps us get that high heat that we're looking for. So we want low oxygen, high heat. So this is after it's finished. We've doused the whole thing with water after burning it for a couple of hours, after we're confident that all of the material has been pyrolyzed. And we've doused it with water to stop the process. If we were to leave it going all day or longer, we would just end with ash, and we would not have a lot of the carbonized material that we are going for. So here are just some more pictures. Here's the retort biochar kiln that I had mentioned earlier. You can see the biomass goes into this center compartment, and then we place that whole thing down within the larger compartment. We add our fire starting material around it, and we get that going. And again, the material in the inner compartment has no direct contact with flame, and it is carbonized. It is not combusting because there is no oxygen. Here's the wood vinegar kiln that we mentioned earlier. Same thing. In this case, the compartment is closed up, and the fire is beneath the compartment, beneath the main barrel, and we have a chimney running up the middle. And that, again, we get that chimney and that draft going, and it really creates high heat, which creates a high quality charcoal. And you can see here on the side of the compartment, we have the condenser chamber where we collect that liquid smoke for the wood vinegar that we're going for. Okay, so one of the questions we get is, how do you know if you have good charcoal or not? How do you know if you're creating high quality biochar or not? And the answer is there are different levels of carbonized material. there's bad carbonized material and there is high quality carbonized material. So some of the more primitive systems that I showed earlier will tend to produce a lower quality charcoal, and that's fine. And that's good for use in soils and soil amendment. We don't need a high quality charcoal for adding to the soil. But if you are making charcoal for water filtration, we do want high quality. We want a high quality activated charcoal. So we would use one of the more sophisticated systems that we showed you, especially that one there at the end, where it's completely closed off and there's no contact with flame. So how do we test it? Basically, a high quality carbonized material will conduct electricity. If we've done our job right and we've made a good charcoal material, it should be remaining intact, and the carbon component should be intact. It should be essentially frozen in place. And so if that's the case, it will conduct electricity. So we can put a live wire and a neutral wire and see if it conducts electricity. And we use the light bulb here to know if it's working or not. So on a low quality charcoal, it will not conduct electricity. On a well-made charcoal, it will light the light bulb right up. Okay, so just to finish out this quick presentation on biochar, I want to just kind of come back and circle back around to some of the reasons that we do this. Why are we making this? Why are we talking about biochar? So like I said, we really encourage the production of biochar to be done with waste material. And doing this is a way to take care of waste on the farm while simultaneously creating something of value. And that's really the take-home message here for the small-scale farm. At Echo, we like to say, take what you have to make what you need. And so it's a way to take something that we would have burned, we would have thrown away, and to turn it into something useful, such as a soil amendment or a water filtration material or even a fuel. If we look at the larger scale, if we zoom out and look back on the global scale, it's also a way to address climate change in a small way. Instead of burning all of these materials and putting that carbon back in the atmosphere, this is a way to keep it where it belongs, and that's in the soil. And that's a good thing, especially in a region of the world that burns and has a smoke problem and an air pollution problem. So this is one small way to take care of some of that material in your farm and make use of it instead of sending it to the atmosphere. So there are many ways to make biochar. There are many different techniques. This was just a very quick overview of what is biochar and how we make it at Echo. And we just want this to be a jumping off point for you. And hopefully you can follow up through more resources that we have online, and hopefully through further training and interaction. And we hope to be able to discuss this in person and answer some of your questions. So thank you for joining us today for this quick overview of the topic of biochar. We'll see you later.